Hello, everyone. Thank you for joining us today and welcome to our webinar. My name is Danielle Zeiss and I'm the Senior Marketing Manager here at KubeCost, and I'm joined by my colleague, Sean Pomeroy, who is a Lead Solutions Engineer, and he'll be presenting the webinar for you today. Today's discussion is going to be focused on attributing cloud costs to Kubernetes applications. But before we dive into the technical session, I wanted to just provide you a brief overview of KubeCost. So if you're not familiar with us already, KubeCost is a tool that helps organizations monitor, analyze, and optimize their Kubernetes cluster usage in order to reduce cloud costs without sacrificing performance or agility. Our platform provides insights into resource utilization, application health, and performance, as well as real-time alerts when thresholds are exceeded and cost projections based on the usage patterns. Our recommendations are based on analysis of usage data, and it's all in one place, making it easy for teams to stay on top of their cloud spinning while also having access to the latest features available in Kubernetes environments. So today, Sean's going to walk you through the presentation, and we'll leave some time at the end for any questions. But I also wanted to flag that we'll be recording today's session, and we'll send out a video of it all after the session's ended, just so you have it. So with that, I'll go ahead and pass it off to Sean.
Perfect. Thanks so much, Dee. Really appreciate it. So just a quick bio on me. So like Dee said, solution engineer here at KubeCost. Been here for just over 2 years. And prior to, I've been in the cloud cost optimization space for going on about 8 years. I'm happy to bring to you some of what KubeCost can do to help you understand your application costs, both in Kubernetes as well as outside. So let's go ahead and get started. So we're going to cover a few different topics today. I'll try to keep the slides light. I know everyone prefers more hands-on as opposed to presentation, so I'll do what I can there. But we're going to touch on cloud cost reporting, what's possible today within the cloud providers, what to be aware of when getting into the Kubernetes layer and how to allocate costs there. And then, of course, introducing you to some of the solutions that KubeCost can help you to better understand the cost of those applications, both within Kubernetes as well as the cloud native services they may be consuming. So first, cloud cost reporting. So many of you are likely familiar with, the cloud operating model, how you purchase services, how you're charged, how you invoice, and, some idea on how you can look and filter and view those costs within the cloud native consoles and reporting tools that they provide. Talking about kind of like what we support, but obviously this plays well with most cloud providers. So Alibaba offers some billing management features. They also offer an export, very similar to what the rest of the providers offer. AWS, everyone's probably very familiar with Cost Explorer and the way that you can slice and dice your information there based on region, service, account, as well as things like tags and labels. Azure, very similar concepts, cost management and billing. They also have a cost export, very similar to the AWS cost and usage report. And then, of course, GCP also has a console-based view to your costs, and they allow you to export your cost data to a BigQuery database and table that you can then query for additional insights and information. One of the things we want to cover today is that, obviously many customers and many people operating in cloud are consuming more than one provider. So it's really ideal to have a solution that can allow you to aggregate your costs across all of those different environments. Just a few shots here on all the different options that are available to you. One of the key concepts time and time again that we kind of always come back to when talking about FinOps and allocating costs within the cloud and Kubernetes is a concept of tagging or labeling, because this gives you a construct that can remain the same across all your providers instead of relying on some of the more vendor locked-in type constructs they may provide. Just quick overview on tagging. So, key value pairs, right? Important to identify what you want to track from a cost perspective. There's a whole concept of crawl, walk, run within a FinOps foundation type world. So typically we start very low level, just understanding what applications belong to like which cost centers or business units, and then get kind of more deeper and deeper as the company gets more mature with that operating model. So some concepts may be cost center, business unit, team, application, and then as you get more granular with like things like service component in the actual specific applications. It's really important to consider use cases for both finance as well as actual the different departments that may be consuming those reports and those resources as well. It's really important upfront to define standards. So once you decide what you want to report on, make sure you define standards like the name and what to keep in mind when creating those resources and what you want to track. The next step would be obviously tagging those resources. Most companies don't implement a tagging and governing policy until they're already operating within the cloud. So there's going to be some retroactive work that needs to be done to bring all the existing resource into compliance with those new rules that have been defined. And then of course, governance, right? Having standards around tagging your applications, your resources, especially from a cost showback or chargeback perspective, you want to ensure that you have governance around the application of those tags to ensure that they are applied to the resources, at creation time or soon after, and ensuring that the values of those tags meet the requirements for what you're looking to accomplish. As part of the effort to put together this webinar, I gathered some information around the different cloud providers and Kubernetes environments on what it means from a tagging and labeling perspective, kind of what to keep in mind. Because for those customers that operate across these different mediums, you want to make sure that what you do decide on from a tagging or labeling standard can be used across all those different environments. So I just kind of captured kind of the high level requirements for tagging across the cloud providers as well as Kubernetes. Most are similar, right? How the length, how many tags you can have, the length of the key, the length of the value of the key. A common theme that we encounter is case sensitivity. So some providers require that keys and values are case sensitive, others don't. Some are only lowercase, some are just on the value. And then additionally, the inclusion of symbols. Probably the biggest difference here between cloud and Kubernetes is that Kubernetes labels can contain fully qualified domain names and subdomains as a feature of those labels, whereas many of the cloud providers don't allow those special symbols within the key itself of the tag. Also, different providers use different names, right? Tag is far and wide the most common name for the concept, but we also see Google Cloud using label. They also have the concept of tag, but that's more specific to networking components. And then of course, because Google gave birth to Kubernetes, Kubernetes also used the name of label for those key value pairs. As Dee said, we'll be sharing the recording with you guys, so this resource will be available to you after the fact as well. The important things to keep in mind as you do implement these tagging plans is not all resources support tags, right? So the cloud providers have very detailed lists in their API documentation on which resources support tag. Additionally, not all tags are always included in the bill. AWS is the standout here. You have to tell AWS which tags you want to be included in the bill. They're called user-defined cost allocation tags. So just because a resource is tagged does not automatically mean that that tag will appear in the bill. Most providers require the tags to be in English. Some do support internationalization. I believe it may only be Google Cloud. So the recommendation there is to stick to English when all possible. And then of course, the whole point of key value pairs is the tag always must be unique. So if you're setting, say, a tag of cost center on a resource, you can't set that tag multiple times. Every time you set it, it's essentially overwriting the previous tag. Okay. All right, so the next step here is talking about and understanding Kubernetes cost complexities. So we all know cloud is complex, cost allocation in cloud is complex. Kubernetes is arguably a bit more complex. There's a lot of different concepts to be aware of, right? So in a Kubernetes, like general overview of hierarchy, you have a cluster contains many nodes, the cluster can contain many namespaces can contain many deployments, so on and so forth, right? It kind of keeps getting deeper and deeper as you drill down into that hierarchy. So talking about like allocating costs, it's important to understand how you should be allocating costs, right? How do you define a tenant within Kubernetes? How do you define an application and track that? Labels, again, really common theme and a great way to allocate those costs across all of those different concepts. Kubernetes has the concept of usage versus requests, right? When you deploy an application, you can tell the scheduler that I need this amount of CPU, or I need this amount of memory. And then, there's going to be a difference between that and what you actually consume. So how do you take that into consideration when you allocate costs? What about idle capacity, right? On top of all the resources running within the cluster, there's always going to be some part of that hypervisor that is neither being requested or consumed. What do you do with that? There's a cost associated with that. Shared costs, right? Especially when you're operating a managed Kubernetes offering like AWS EKS, Azure AKS, Google GKE, there's a tenancy fee involved, right? Because the cloud provider is managing the control plane for you. There's a cost associated with that. So what do you do with that tenancy fee, that cost of that management plane? The other shared costs could be like license costs, right? A lot of clusters are running licensed pieces of software. KubeCost is a great example. There's a cost to running those resources on the server, not only from a resource perspective, right, the CPU memory that they're consuming, but also the license, right, the cost to acquire that software. You know, a great example would be like observability tools, right? Maybe you're running something like Grafana Enterprise Metrics or Datadog or New Relic or some of these other monitoring tools, or maybe a security suite, right? Maybe you're running constant vulnerability scans within your environments. Discounts, right? A lot of tools can help you understand the cost of the resources in your environment, but a lot of them are based on on-demand public rates, right? And a lot of large enterprises have negotiated discounts with the providers, or they're leveraging concepts such as saving plans or RIs, you know, basically committing to usage over time. And then, of course, there's the concept of spot nodes or preemptible nodes across different providers, where you can basically use that slack capacity that the providers have. They're offering it to you at a greater discount. The caveat there is that, you know, they can take it back whenever they want. And then, of course, most providers, when you look at the price of an instance, say in AWS or Azure, you're looking at the total price of that virtual machine, right? But from a Kubernetes perspective, you know, some applications consume more CPU than memory, or vice versa. And then, of course, there's the AI/ML tasks that are going to consume GPU resources on the nodes. So how do you weigh the difference between an application that's consuming more CPU than RAM or one that's using GPU, right? Always really important things to consider when you're talking about Kubernetes resources. And that brings us to OpenCost. So for those that are not familiar with OpenCost, OpenCost is two things. So number one, it's a specification, vendor neutral, specifically on how to do and allocate the infrastructure and container costs related to Kubernetes environments. It's got a lot of great industry contributors, right? The big three cloud providers are all involved in OpenCost, as well as companies such as Adobe, Grafana Labs, and New Relic and SUSE. Additionally, OpenCost is open source software. So basically, it's the core cost model engine on how to do Kubernetes cost allocation. It was donated to the CNCF by KubeCost, who are the original creators of OpenCost, and is currently a sandbox project within the CNCF. And it is the core cost model engine behind KubeCost as well. So what does allocating Kubernetes look like? So there's a number of different sources. I'm going to be talking from an OpenCost/KubeCost perspective. Different vendors may do this a bit differently, but obviously we believe this is the best approach to do it. So we're using a combination of a few different sources of metadata. So number one, resource consumption, right? What are the different containers requesting and what are they consuming within the cluster? Resource cost, right? What are the underlying nodes cost? Is it associated with an enterprise discount? Is it covered by an RI savings plan or spot node coverage, right? The Kubernetes API. So we get workload metadata, right? What tags or labels are all these resources? What annotations are in place? How long has the container run over a given period of time? KubeCost then takes all of that information, does some calculation, and emits what we call an allocation, right? Which is essentially the cost of a resource based on all of these different factors. We're doing this every 60 seconds, so it's actually in very near real time. And then additionally, we ingest the cloud provider bill to properly reflect those discounts. There can be a delay there, anywhere from a few hours to a few days, depending on the service and depending on the provider. An important concept of that allocation is how we allocate costs based on usage versus requests, right? As I said earlier, when you deploy an application to Kubernetes, you have the option to specify what the requested capacity, in other words, what from a resource perspective is this application going to consume, right, for CPU and memory. And then what actually happens can vary differently depending on the application. So we look at both those values, what's being consumed, what's being requested, and then we always take the maximum of those two values. So like, let's say an application is requesting one full core of CPU, but it's only requesting half a core. KubeCost would calculate the cost of that based on the requested capacity, because that's what the Kubernetes scheduler is setting aside to run that resource on a node. On the flip side of that, let's say that same workload is now consuming 1.5 cores. Now KubeCost switches to calculating the cost based on the actual consumption of the resources. So always the higher of those two values. which brings me to idle capacity, right? So a lot of people consider idle capacity the difference between requests and usage. We do it a little bit differently because we always take the maximum of requests and usage. So it's not really an idle cost to that. There's an efficiency calculation that's a little bit of a different topic. But we essentially define idle as the slack capacity in the cluster. So think of this as the difference between what's been allocated to the resources running in the cluster and the total provisioned capacity of the underlying hardware. Every Kubernetes cluster is going to have idle. It's an important concept for Kubernetes because you need the ability to scale. The question always becomes, there's a cost to that. What do we do with that cost? And KubeCost can give you a few different options on how to allocate that. Number one, we can just give you the visibility so you can understand what the idle cost of that cluster is. And number two, if you don't care at all, we can completely remove it. You don't even have to worry about it. But more importantly, on a showback more of a chargeback basis, is we can distribute that idle. So we can distribute it to the cluster as a whole. Basically, every workload pays a proportional fee for the idle capacity, or we can share it by node. Node makes more sense if you've basically condoning a bunch of workloads to specific nodes using a bunch of taints and tolerations, and you want to make sure that those different applications are responsible for the idle capacity on the nodes that they're consuming. By default, we're going to distribute this cost proportionally based on consumption. So if you have a resource that's consuming 20% of the total cluster capacity, the same resource can be responsible for 20% of the idle cost as well. Once all the information is calculated, we render it within our UI. Everything is also API accessible, programmatically accessible, so you can work with the data directly in the UI, for the different financial folks, or for the different engineers or maybe business processes that want to consume this data programmatically. We do expose JSON, CSV, as well as PDF as endpoints for extracting the data from KubeCost. And then, of course, we do alerting and notification to make you aware of like scheduled reports, cost anomalies, or efficiency. And efficiency is an important metric that I don't have a slide on, so let's cover it real quick. Efficiency is a simple calculation on how effectively a resource is consuming its requested capacity. So essentially, a low percentage is going to dictate that the resource is over provisioned, right? It's not consuming what has been requested. And then a high percentage, over 100% would dictate that the resource is under provisioned. In other words, it's constantly consuming more than the request capacity. Both situations can lead to some issues within the Kubernetes cluster. So we typically target somewhere between 60 and 80% efficiency, depending on the cluster, depending on the environment, and depending on the underlying applications. All right, so that brings us to advanced reporting, the main reason we're here today. KubeCost Advanced Reporting aims to solve a few different use cases. The two we're going to talk about today is the first one is going to be what we call out of cluster cost. So that's basically in an organization where much of the workload is Kubernetes, and say those applications are consuming resources outside of the cluster. That's going to cover that type of use case. And then we're also going to introduce a brand new release we're calling cost center reporting. So essentially that flips the script a little bit, and now we're targeting a cost center which can include costs both from Kubernetes as well as your cloud bill. So starting with out of cluster, so this is a feature we've had for a bit, still in beta because we're still fine tuning kind of how it works and how it operates. Essentially, the thought process here is that an application running in Kubernetes that consumes resources out of the cluster, a good example would be something that, say, uses Amazon RDS as a backing database. Most companies want to understand that the total cost of ownership for running the application, which would include those external services. So we provide a mechanism based on tags to pull in the cost of those resources when we query your cloud bill. Concepts include basically all the different Kubernetes levels. I'd say namespace and label are probably the two most dominant that we hear on a regular basis. And basically, as you label those resources or tag those resources in the cloud provider, when we ingest the bill, we give you a way to tie those resources to specific Kubernetes concepts. And we'll break into a demo here shortly. And then the next one is the cost centers. So cost centers, think of this as kind of the more normal way to allocate costs from FinOps perspective in the cloud world. So basically similar to out of cluster, except the focus on combining costs into what we're calling a cost center, right? So that may include cloud costs, that may include Kubernetes costs, but the important concept here is it's not essentially dictating that the cost is specific to like a Kubernetes application, right? You're combining the costs from all those different areas. All right, and with that, let me go ahead and switch over to our demo environment here. So just kind of looking at the allocation view as the main view within the platform, right? So this is the slide I showed you previously. Understand the cost of all your different applications within Kubernetes, showing that idle capacity signified by this line item here in the chart, as well as the gray bar in the graph above. And then, as I said, you have the ability to kind of queue in how you want to see that data. I can very simply hide it, so I don't even have to consider idle here. Or from a chargeback scenario, like I said, typically want to share that with different resources. So now all the different namespaces in this case are sharing the cost of that idle capacity. Talking about advanced reporting. So for those that have kubectl deployed, advanced reporting has been around for a while. The out of cluster one specifically has been. You can get to that by going to reports, and you'll see a link up top says visit the new advanced reporting page, which will bring you directly into the out of cluster view. By default, we're going to configure this based on our tagging schema, right? So looking at the previous slide, these are the default tags we're going to be looking for. If you already have tags in place that map to Kubernetes concepts, we do have the ability to override these and use your specific cost allocation tags. But essentially what happens when you come in here is you define the period of time you want to look at, right? Let's say like last 30 days. What we want to aggregate by. So aggregation is a kubectl concept for Kubernetes, right? So we want to aggregate by one of the different pieces of the hierarchy. So in this case, we're going to pick namespace. And then the cloud breakdown. So cloud breakdown today supports provider, right? So that's going to be your AWS, Azure, your GCP, service, right? Amazon EC2, Microsoft Storage, GCP, SQL, so on and so forth, or account, right? So that's the actual, your AWS account, your Azure subscription, your GCP project, and then of course label, which is what we're going to be using today. So mapping to Kubernetes namespace. Down the bottom chart, you'll see this looks very similar to our allocation view. The biggest difference here is the addition of this external column. And you'll see that for most resources, it's 0, except for unallocated, which is fairly large. That's indicating that I have not allocated my cloud costs to different resources. So this bill, if I look at unallocated here, you'll see is fairly large, looking at all the different services we're consuming across all the different providers. But if you look at kubectl here, it also has a magnifying glass, and we've got $258 in spend. And if I click on that magnifying glass, I'm now going to get more insights into where that spend is occurring. Again, I've tagged all these resources in the provider. So because this is kubectl and this is a multi-cloud, multi-cluster demo environment, we are consuming resources from the big 3 providers. So because we're ingesting the Amazon cost and usage report, there's costs related to S3 as well as Lambda here and Glue. For Azure, we're ingesting the Azure cost export, which lives in a Microsoft Storage account. So that's the reason for the Microsoft Storage cost there. And then for Google Cloud, we are ingesting costs from the BigQuery export. So that's why you see Cloud SQL, Cloud Storage, and BigQuery there as well. This information is programmatically accessible, and it can be saved to be more easily reviewed by different parties. So this specific report, I don't have saved, but I pop back over to the reports view. You'll see this lengthy list here. I have a SPOM webinar, application namespaces, so I can very easily pull up. This is like my application view. So I've filtered out all of the other Kubernetes resources that I don't care about using some filters here. So I'm looking for any namespace that starts with kubectl, Acme Fitness, or Pacman, and then I'm showing the costs related to those specific services within this view. All right. From here, let's talk about the cost center reporting. So this one is available in our newest release. So that's going to be version 1.104. To create a cost center allocation report, you would come into that same report view. You'll also notice that the green link that was previously available for standard advanced reporting is gone. Both have been moved to this create a report button. So from here, you can go ahead and create a report. So the last screen I was looking at was the advanced report. So you can click there to create an advanced report. But we're going to be looking at the cost center report. So we'll select that. As most things, the first step is to create a name. So we'll take the same approach that we did with the other report. Call it SPM webinar. We'll give the cost center a name. For this example, we'll just call it ABC. Now we've got a few different options for how we want to show costs. I guess we probably should have started with kind of how we ingest the bill. So those that have seen kubectl before or used the platform before, the way we ingest the bill has changed in the last few releases. We're calling it the Cloud Costs API. Essentially, it's a more performant way to ingest the bill. And with that, we also now gain the ability to look at costs based on the different amortization schedules that different providers allow. I think AWS may be the only one that has more than one option. I can verify that for sure. But so net amortized is going to be the default because they all do provide that type of cost metric. So the first thing we're going to select is aggregation, right? So for a cloud bill perspective, what do we want to aggregate by? I always use service as an example. There's a few other concepts here, right? Provider, account, category of spend, and then of course label. So we'll stick with service for now. We're using the net amortized cost metric. And then for a filter, I'm going to go ahead and filter on that same label I was using for my other report. So Kubernetes underscore namespace equals kube cost. And go ahead and add that to the filter list here. And then for the Kubernetes workloads, I want to go ahead and aggregate by namespace as well. And then I want to include a specific namespace. We'll go ahead and include kube cost here. And you'll notice as I am populating these filters and these aggregations, the report preview on the bottom is changing dynamically based on the selections. So we can essentially see what the output is looking like. So we see cost center called ABC. These first few columns are related to the breakdown of Kubernetes spend, CPU, GPU, RAM, storage, network, and your load balancer fees. And then cloud is the column, very similar to the external column in the last report, that reflects the filtered cloud resources being pulled down from your bill. And then the cost is the total cost of both those resources combined. So if we're happy with this report, we can go ahead and click done now, or alternatively, we can add an additional cost center. So say if we want to do that, we'll call this one XYZ. We're going to filter on the same aggregation. So service net amortized. For this, I'm going to include, actually, I'm not going to include any filter. And then for the actual workload, let's go ahead and make this namespace, and we'll say like kube system for the underlying control plane. So now we've got an additional one, and because I'm not filtering the cloud cost, it's basically the remainder of that bill. And we can go ahead and click done. And now that'll go ahead and save my SPOM webinar report. And now I gain the ability to actually drill into these different cost centers. So we'll go ahead and choose this ABC one. Now we can see our cloud costs. The first question you're going to ask is, well, why does it say Amazon S3 6 times? And that's because this is a daily cost. So basically this is the cost per day of the time when we're looking at, right? Last 7 days. And you can go through different pages here. I'll see all the different services we're consuming, just like we did in the last page. And then the Kubernetes cost, right? So because we filtered specifically on the kube cost namespace, that's the only row that we're going to see here. And of course, idle. So the remaining idle capacity for that resource. We go back to the main one, we can drill into the XYZ namespace. And now we've got a view into kube system. So same concept as looking at kube system as opposed to kube cost, as well as the remainder of all of our cloud costs for the different services we're consuming. Okay. This is the initial release. It's going to get better as we release. We do release monthly, so I'd expect some changes here in the next release. We're planning on adding additional aggregations, right? So if we go back to the create a report and look at the aggregations for cost center. So like today, we're supporting service provider, category, cluster, account. We're going to be adding some additional ones there, as well as some additional tags. Increasing support for cost metrics available across the different cloud providers. Something really interesting that I don't have in my webinar is the initiative called Focus. This is started by the FinOps Foundation. And essentially what it is it's going to be an agnostic approach to billing, and all the cloud providers are contributing to it. So KubeCosts as well is contributing to it and making use of that new Focus specification for cloud cost billing. And then, of course, for the Kubernetes workloads, as we add additional functionality around cost allocation, they'll also be available within this review view as well. And then everything is available from the reports view. Those that are familiar with kind of how KubeCosts can get installed, you'll be able to configure these directly in the UI as well as via Helm. And then if we pop back over to presentation, that was the end of the demo. So now would be a great time to open up questions. I know that we submitted a few earlier on, so I can cover those first and then give the audience some time to add additional questions as they see fit. One of the first questions we had for those that registered was how could it be used with Amazon EKS? So we're actually partnered with EKS, and we have a few different options for more easily deploying KubeCost in the EKS environment. Number one, there's a customized Helm chart specific to deploying against EKS that has some customized values for Amazon. And then additionally, we were one of the lighthouse providers for the add-on marketplace for EKS. So you can very easily go into the Amazon console, go to EKS cluster, enable add-ons, and select KubeCost to be deployed with your cluster. We've got some exciting announcements up and coming there as well. Excuse me. The next question we had was, we are trying to track the cost of a software called Posit, it sounds like, I'm not sure of the pronunciation there, across our clusters. And we are trying to better understand the cost of those different instances. So I'm not familiar with this the software. It depends on kind of how it's deployed within your Kubernetes estate. If it's deployed in its own dedicated namespace, that's very easy and kind of default their default functionality. Alternatively, a lot of companies use labels on the resources to get a better handle on resources deployed, say, across multiple namespaces. The next one was, would the total cost of ownership include the cost of development of an application beside that of the hosting services? No, not necessarily. So we don't have any visibility into the cost to actually create that application. But you could certainly combine those costs, using a combination of the KubeCost data as well as your business costs for developing an application outside of KubeCost. And then the last one, how to connect cost with role-based access control, OPA, HPA, disallowing creating new resources or downscaling if some team exceeds cost. That's a really good question. So one of the new features we have is called KubeCost governance, which introduces the concepts of budgets. So you can tie a budget to a Kubernetes concept, and then you can get alerting and notifications based on the attainment of that budget. So today it's purely notification standpoint. So if I want to say, create a new budget, Sean's budget, $100, say against a namespace, we'll pick on, say, the KubeCost namespace again. We have the ability to create an action here, and the action is going to be, well, where do you want the notification sent, and what is the trigger for that notification? One of the things that we are working on is a cluster admission controller that would be tied to the service. So you can essentially have a check that would verify, number one, what is the current budget attainment for a specific, namespace we'll use as an example. And then number two, what is the predicted cost of this new workload or modified workload? And will that projected cost bring the budget over 100%? And then we can basically take action like, no, we won't allow that workload to be deployed in that environment because of that budget attainment. And I see we have a question in the Zoom chat. Can we add multiple AWS accounts for a cost center? Yes, I do believe so. I have not tried it specifically, so we can kind of jump in here and look. So because we can filter by account, so you should be able to add your AWS account ID, GCP project ID, or the Azure subscription to basically aggregate and filter those costs. So yes, that should be a valid answer there.
All right, thank you everyone for joining us today. We'll be sending out the resources from this webinar in addition to that video that I promised. So be on the lookout for that email. And if anyone couldn't attend today and you want to share the video, feel free to send it to anyone else on your teams. We appreciate you joining us today. Everyone have a good day.
Pleasure talking to you guys. Take care.